Second question. Compound X is a compound of carbon, hydrogen, and oxygen. Question A. Analysis of a sample of X shows that it's 54.55% carbon, 9.09% hydrogen, and 36.36% oxygen by mass. When X is analyzed using a mass spectrometer, the molecular IMP has an M/Z value of 88. Use this information to show the molecular formula of X is C4H8O2. Show all your work clearly. So this question 3 marks. So the percentage composition by mass is given. So using this percentage values by mass values, we can easily identify empirical formula. So we will take our sample X as 100 grams. So when we have 100 grams of X, so there will be 54.55 grams of carbon, 9.09 grams of hydrogen, and 36.36 grams of oxygen. So as we have grams, we can easily identify moles. We need to divide by atomic mass 12, 1, and 16. So first one, if we divide by 12, we get, for carbon we have 4.54 moles, for hydrogen 9.09 moles, and for oxygen we will have 2.27 moles. So moles, so the ratio of moles also shows the ratio of atoms in the molecule. So here we get these numbers. So to make it whole number, we need to divide by the lowest number. So here 2.27 divided by 2.27, here 2.27, here 2.27. So it's obvious that here we have 2, here we have 4, here we have 1. So ratio is 2:1. So the structure will be C2H4O. But this is, don't forget that it's empirical formula. Empirical formula shows the simplest, the lowest possible whole number ratio of atoms in the molecule. Empirical formula. So what's next? You are given that from mass spectrometer the molecular IMP has M/Z value of 88. So we can identify molar mass of empirical formula C2H4O, which is 44 grams per mole. So molecular IMP, that M/Z value of 88, means that molar mass of your unknown compound is 88. So what does it mean? So if we put n here, we can identify to what number we need to multiply. So 88 divided by 44, so you get 2. So you multiply by 2, this structure. If you multiply by 2, you get your answer. So C4H8O2. Very simple. So if you do like this, so you get all 3 marks. Next question. Next question involves NMR spectroscopy. Okay. B. When X is analyzed by proton NMR spectroscopy, the spectrum below is obtained. So before going to the questions, let's analyze the structure. Analyze the spectrum. So here you can see that we have a single line or we call it singlet. Here we have you can see that triplet. Next one, we have this one is a little bit complicated, but it can be determined. It will be multiplet, or we can write. So here we can see that it is sextet, and this one is also triplet. Why we have this kind of specters, so signals? So singlet, what does mean singlet? So this is proton NMR. So we're looking to hydrogen. Singlet means by n+1 rule. Don't forget n+1 rule. So n+1 rule gives us singlet. So n+1 rule gives us singlet. So n means 0. 0 hydrogens on adjacent. So here 0 hydrogens, 0 on adjacent. So let's write OH. 0 hydrogens. Triplet, 2 hydrogens. So n+1 equals to 3. So 2 hydrogens. Sextet, 5 hydrogens, and triplet again 2 hydrogens. Okay, so now we read our spectrum: 0 hydrogen, 2 hydrogen, 2 hydrogen, 5 hydrogen. Okay, let's move to the questions. So question I, explain why the peak at 0.6 is split into triplet. So we already explained. So because on adjacent we have, so we can write by n+1 rule, it can be determined that there are 2 hydrogen atoms on adjacent carbon, so neighboring carbon. So 1 mark. So by n+1 rule, it can be determined that there are 2 hydrogen atoms on adjacent carbon. Okay, next. Deduce the structural formula of X. Use the proton NMR spectrum to explain your decision. Identify the protons responsible for each of the absorption in the spectrum. So first, let's remember that we have formula C4H8O2. C4H8O2. So from data booklet, if you use data booklet, in the data booklet you will see that this region shows signal. So between 10 and 12 we have carboxylic acid. So remember carboxylic acid. So in carboxylic acid, so we must have C double bond O OH bond. C double bond O OH bond. So here we have 5 marks. So C double bond OH. So because of signal between 10 and 12, yeah, you can get 1 mark for this. Next, so from I we can see that 0.6 is triplet. So we have something which has 2 hydrogens on adjacent carbon. So now we will construct. So from data pocket you can also see that this value 0.6 value shows your structure contains CH3. CH3, so 0.6. Here we said that also this hydrogen on adjacent carbon wouldn't have hydrogen, so 0 hydrogens. So CH3, 2 hydrogens. So here we can deduce that CH3 is connected to CH2. Okay, so now let's see the second one. So sextet, 5 hydrogens. So 6 that 5 hydrogens. So it can be CH2. From both sides we have hydrogens. So this is value is 1.5 something like that. 1.5 hydrogens. So on both sides we have hydrogens. Again, last one, triplet again. Triplet. It can be again CH3, but from data bucket you can see that it can be CH2, which is connected near to the electronegative elements. So here we have oxygen electronegative element. So this is around 2, and also has how many? 2 hydrogens on adjacent. Okay, when we construct the structure, so again this is carboxylic acid. So carboxylic acid is at the end, of course. So we have here C double bond O OH, and we have here CH3 also, which will be at the end, okay, because it's only connected by single bond. So here we have CH3. Now we only left with 2 CH2, so we just put CH2 and CH2. So this value, so let's say so this CH3 is because of this carboxylic acid here, and this CH2. So 5 hydrogens is this one, and this CH2 is this one. Okay, so this is butanoic acid. Butanoic acid has this kind of proton NMR spectrum. Okay, so please don't forget about analytical techniques. Now next question. So we have butanoic acid. So C. X has 4 structural isomers, all with the same functional group. This functional group, which may be hydrolyzed by hot sodium hydroxide, aqueous solution of hot sodium hydroxide, is different to the functional group in X. So that means different to the function group. You have structural isomer. As we have as we said that we have here butanoic acid, different functional group. That means you have functional group isomer. Functional group isomer for carboxylic acid is ester. Okay, ester. Functional group isomer for carboxylic acid is ester again. So you just construct ester, which has molecular formula of C4H8O2. Remember, the general formula for ester is R, C double bond O, single bond O, and R. Okay, so it will be easy now. So we identified that it's ester, so just we can put here, let's put here methyl, CH3, C double bond O, and we use 2 carbons, so here we need to put 2 carbons, so it will be CH2, CH3. And name, so when you name ester, you name this part, which will be substituent, so ethyl, and here we have 2 carbons, and this part made from carboxylic acid, so it will be ethanoate, ethyl ethanoate. Okay, next, another isomer. So if we put methyl on this side, so let's see, we'll have CH3, CH2, C double bond O, and CH3. So this, now we have methyl, and 1, 2, 3 carbons, propane, O8. Very easy. Okay, so different to the functional group, so it means you have functional group isomer. Okay, so carboxylic acid is functional group isomer to ester. So please remember how to name esters also.